So pH is basically a useless indicator. pH will tell you that you have how much hydrogen you have in your soil. And hydrogen in your soil isn't really a plant nutrient. So pH is potential hydrogen. And potential hydrogen ions that are stuck on your soil colloid. And what you have to know about hydrogen is that whenever you have a blank space on your soil, so if this is your soil, a sheet of clay soil colloid, you have little binding sites all over it. You have this would have 8. And then you've got 4 calciums, 2 magnesiums, a potassium, and a whole bunch of other things making up a partial one. But if you strip off a calcium, you now have an empty space. And that empty space will fill with hydrogen, all else being equal. That'll fill with hydrogen. And if you fill a couple with hydrogen, you'll end up with 10, 15, 20 or more % of them covered in hydrogen. And so that would be a pH of 5, let's say. So 20% of your little spaces are hydrogen. You've got a pH of I forget, but it's 5 point something. So you'd have a low pH. Okay, so you have a low pH. So conventionally they tell you that you need lime. But they don't tell you what kind of lime, because the conventional world doesn't necessarily appreciate this. When they talk about pH, it's just how much lime you need to add, or how alkaline your soil is out west and in where I live, in New York. So the problem with pH is that there are many things that influence it. So there are many ways. It just tells you that you're deficient in something. So if you have a low pH, it means you're deficient in at least one cation. And it could be calcium, it could be magnesium, it could be potassium, it could be sodium. So if you have a low pH caused by low calcium, you may in fact have excess magnesium, and you may have, let's say, deficient potassium as well. And if you go by the standard recommendations from places like Yukon, not to pick on specific soil testing labs or anything, but they will just tell you to put down so many pounds of lime to treat that pH, 5.6 pH. And they'll tell you generally buy the cheapest lime, because it's all the same, because it's just about pH. And if you buy the cheapest lime in Connecticut, they're going to probably sell you dolomite. And dolomite is 11% magnesium and 22 to 30% calcium. And if you do that, your high magnesium will get higher, and your pH, yeah, sure, it'll go up towards neutral. Likely, though, if you had a pH of, say, 5.6, and you put down the amount of lime that they told you, you'd end up with calcium at 50-something % and magnesium at 20-something %. And your soil will be hard as a rock, and your plants would still exhibit signs of calcium deficiency. They'd likely show signs of magnesium deficiency, despite having too much, because your soil's so tight. And you'd never factor in, and you'd never probably think that you had too little potassium either. But potassium and sodium, for instance, have a larger impact on pH than calcium or magnesium. And so instead of looking at pH, it makes more sense to look at your base saturation percent of the cations. So your calcium, your magnesium, your potassium, your sodium. And you want your calcium, for the sake of keeping it simple, you want calcium at 68%, you want magnesium at 12%, you want potassium at 5%, you want sodium at 1 to 2. That's your ideal balanced soil. If it's very sandy, it changes it a little bit. For the sake of argument, that's what you want: 68, 12, 5, and 1. And so, let's say you, in this example, you have low pH, you have high magnesium, low calcium. That's what's causing you have low calcium, low potassium. That's why your pH is 5.6. It would be 5, except that you've got excessive magnesium. And so you need a calcitic lime. You need high cal lime, no magnesium. You need sulfur to help get rid of the excess magnesium. And then you'll end up, if you balance it all after a couple of years, you'll end up at a pH of 6.4, and it's magically perfect. The alternative sort of scenario would be you have a pH of 7.2, and there's very few labs in the world who will look at a 7.2 pH and tell you that you need limestone. But there are places I have worked where they actually have pHs of 7.8, 8, and 8.2 in that range. And with super high exchange capacities, they're like super heavy clay soils, and actually clay soils, not like what we complain about in New England. And they had pHs of around 8. No one in their right mind would ever recommend that they put lime down, except us. Because the reason they had a pH of 8 was because they had something like 10% sodium, 10% potassium, and like I said before, potassium and sodium have a higher impact on pH than do calcium and magnesium. So they had 10% sodium, 10% potassium, I think 30% magnesium, which is, if you remember, about 3 times higher than they wanted. And they had calcium that was like 25%. So like really screwed up soils. And we came in, we put down, I think it was 3 tons or 4 tons of high cal lime and 4 or 5 tons of gypsum. Don't do this at home. Do not do that unless you are in Minnesota on super muck clay soils with 10+% sodium. But in this case, we put down high cal lime and gypsum, and the pHs went from 8 to 6.8.
Wow.
Which is like, no one thinks this is possible. Well, how could that happen? And it's because when you add limestone, you have a tangential impact on pH, but it's tangential. What you're really doing is you're affecting the mineral balance. Your calcium, magnesium, and the balance of your other cations. So in this case, the excess calcium, the calcium we put down, helped to remove the excess sodium and potassium, which were the things that were keeping the pH really high. So, by the way, nothing grows in that soil. It was literally barren soil at the side of the road. It was black clay soil with a white layer of salt on the top. Weeds would not grow there. And after doing this, it became their best part of the fields, I think 2 or 3 years later. Anyway, so that's sort of the pH story.